Good day, geographers, and welcome to another episode in our practical geography series. You know, the one you like to call Map Skills. I'm your host, Donovan Rattray. Well, today we are going to be doing gradient. So, what is a gradient, you might ask? Well, picture this, students. A company that is contracted to either lay fiber optic cables or pipelines or construct a railway line or a road or even a building in a particular area have to carry out an assessment. This kind of assessment is what we call a gradient. Now, if the gradient turns out to be favorable, they will carry out the project as scheduled. But if it is calculated to be unfavorable, then they have to abandon the project in that particular area and take it somewhere else where the gradient, when calculated, may just be favorable for the project to go on. Well, you're still wondering what we call a gradient? Well, basically, gradient is the rise of the land over a given horizontal distance. In other words, students, it is either how gentle or how steep a slope is. If the land is too steep, then for a project to continue, it may just be abandoned. But if it is ideal, if it's gentle enough for the project to go on, then they will do the project. The gradient, when calculated, must either be expressed as a ratio or a fraction. Now understand this, class. The greater the ratio or the fraction, the gentler the slope is. The lower the ratio or the fraction, the steeper the slope will be. Here is a diagram of a slope. And along this slope, we have 2 points. A point A right here and a point B down here. Now, we're going to assume, as you can see, they're both far apart from each other. So let's assume then that the distance between point A and point B along this slope is 10 kilometers. Class, this 10 kilometers, which is the distance between 2 points along the slope, is what we call the horizontal distance. Once again, here is our slope. But this time, let us change the points a little. So, again, we have a point B down here. Our point B is 50 meters high. And our point A up here is 500 meters high along the slope. Now, whenever we are calculating gradient, it is important that we find the difference in height between the 2 points on the gradient. All right? So we have a point A at 500 meters and a point B at 50 meters. Now, we have to calculate the difference in height. Now, the difference in height, when we subtract our 50 meters from our 500 meters, we get 450 meters. This 450 meters, which is the difference in height between the 2 points along the slope, is what we call the vertical difference or vertical interval. It doesn't matter which term you use, it's the same thing. But the most popular term that is used, especially here in the Caribbean, is vertical difference. But then again, as I said, vertical interval is also used, and it's perfectly okay if you use it. So here we have an example of a steep slope. The one that I showed you earlier would have been an example of a gentle slope. Now, look at this slope right here in the foreground. Do you think it's a steep slope or is it a gentle slope? Well, if you said it's a gentle slope, no, you're not correct. It is actually a steep slope. But if you say steep, more power to you. Well done. What about this one? Is it a steep slope or is it a gentle slope? Okay, very good. It is indeed a gentle slope. So here we have our point, here we have a slope, and obviously it's a steep slope, right? So we have up here point A, down here we have point B. Point A and B are apart from each other. Now let me ask you this question. What do we call the distance that separates point A from point B along a slope? Do I hear horizontal distance? You are indeed correct. But let's now assume that the height of point B is 135 meters. Sorry, point A is 135 meters and point B is 66 meters. We now have to calculate the difference between these 2 points, which will give us 69 meters. Now the difference of 69 meters, what is the proper term we use to give to that 69 meters? Did I hear vertical interval? Did I also hear vertical difference? Well done. You are both correct. Well done, everyone. So, the vertical interval or vertical difference is the difference between the highest point and the lowest point along the slope. The horizontal distance is the distance between the highest and lowest points along the slope. And here is the formula for finding gradient, which is gradient equals vertical difference, or as we also call it, vertical interval all over horizontal distance. All right, so let us now try to work out a gradient. So we have here the church at Chapelton, which is at 350 meters. We have a school near Frankfield. It is located at a height of 120 meters. And both the church and the school are actually 15 kilometers apart. Let us calculate our gradient. Now, if you noticed, looking at the information given, something is a little off, right? Both the heights are in meters. The distance between them is in kilometers. Now that is going to pose a bit of a problem. We cannot just calculate it just like that. We have to do something else. We have to now convert our 15 kilometers into meters. That is what we have to do. I mean, think about it, students. Both heights are in meters. So majority rules, right? So we just convert our kilometers into meters so that everybody can live in harmony. All right. So remember that 1,000 meters is equivalent to 1 kilometer. Therefore, if we convert our 15 kilometers into meters, we will get 15,000 meters. And that is what we need to do in order to properly calculate our gradient. So now that we have achieved converting our kilometers into meters, let us go right into the fun part. First of all, we state our gradient, which is gradient equals vertical difference over horizontal distance. And this means we are going to subtract our 120 meters from our 350 meters. And this is going to be all over 15 times 1,000 because we're now going to convert our 15 kilometers into meters. So 120 from 350 will be equal to 230. And 15 multiplied by 1,000 will be giving us 15,000. All right. Now, we are going to cancel out our zeros. And we're going to now say 23 into itself is 1. And we say 23 into 1,500 is 65. Therefore, our gradient will be 1 to 65, which is the ratio or 1 over 65, which is the fraction. Remember, students, we can actually convert or present our answer either as a ratio or a fraction. All right? So when we work it out, we get either 1 to 65 or 1 over 65. That is our gradient. Class, what does all of this mean? What does this 1 to 65 or 1 over 65 mean? There is a meaning behind it, and that is the reason why we have to do it this way. What this actually means, students, is it actually means that for every 65 meters traveled along the horizontal distance, the height of the land increased by 1 meter. That is what our answer means. Once again, the gradient that we just got a while ago, the 1 over 65 meters or the 1 to 65 meters, actually means that for every 65 meters traveled along the horizontal distance, the height of the land increased by 1 meter. All right? That is what our answer means. That is the reason why it is important that you must always state your gradient as either a fraction or a ratio. If it's going to be a ratio you want to state it as, make sure that the antecedent is always 1 whenever you work it out. Any other number, you are wrong. And if it is going to be a fraction, make sure the numerator is always 1. Any other number that you work it out to is going to be incorrect. So make sure you do that. Okay. All right, now geographers, let us try another situation here. So the height of Goat Pen Hole along the coast is 0 meters. Usually 0 meters means at sea level. So whenever you see that, you know what it means, at sea level. Then the height of the postal agency at Smith's Valley is 200 meters. The distance between the coast at Goat's Pen Hole to the postal agency is 4 kilometers. Let us now calculate the gradient. So in the first step in calculating our gradient, we must state our formula for calculating gradient. So we say gradient is equal to vertical difference over horizontal distance. Now we type in our numbers. So we say 200 minus 0 all over 4,000. Now, how did we get that 4,000? Remember, we simply multiply 4 kilometers by 1,000 meters, since 1 kilometer is equal to 1,000 meters. So we had to convert our kilometers into meters, since our heights are both in meters. Okay, now that we've gotten that out of the way, we end up with 200 minus 0 all over 4,000. Then we divide our vertical difference by our horizontal distance. And this is how we do it. First of all, we cancel our zeros. Then we say 2 into itself 1 time. And then we say 2 into 40, or 40 divided by 2, is equal to 20. Therefore, our gradient will be 1 to 20, or 1 over 20. Which basically means that for every 20 meters traveled along the horizontal distance, the height of the land increased by 1 meter. And that is our gradient. And that is the main reason why we put it either as a fraction or a ratio, so that our explanation makes sense. Now students, what if you were asked to calculate the gradient of a slope with only being provided the 2 points on the map? Now, having found those 2 points, you now would have to measure the horizontal distance, and also try to take note of the height of those 2 points by looking at the contour lines. So here we have our situation played before us. We need to find the gradient of the slope between point X and point Y. Point X is at 140 meters and point Y is at 20 meters. So what are we going to do now? Now that we know what the height of point X is, which is 140 meters, and we know that the height of point Y is at 20 meters, we now have to go ahead to measure the horizontal distance between point X and point Y. To achieve this, we use our ruler and our pencil to draw a straight line connecting point X to point Y. Then we place a strip of paper along that line. Now we use our pencil to mark on the paper where point X is and where point Y is. Now, having marked off our 2 points on our paper, we are now going to move our paper right here along our linear scale. So we have where point Y and point X are on the paper. As you can see, the distance between point X and point Y is approximately 3 kilometers. Now, we go into our workings and we state the formula of our gradient, which is vertical difference over horizontal distance. The two heights being 140 meters for X and 20 meters for Y, we are now going to calculate our vertical difference and divide it by the 3,000, which we had converted our 3 kilometers into meters. So 20 subtracted from 140 will give us approximately 120 all over 3,000. Now we go ahead and we cancel our zeros, and then we say 12 into itself one time. 12 into 300 goes 25 times. Hence, our gradient will be 1 to 25, or 1 over 25. Which basically means, class, that for every 25 meters along the horizontal distance, the height of the land increases by 1 meter. Once again, all this means to say is that for every 25 meters along the horizontal distance, the height of the land increased by 1 meter. Now here we have our map of Port Antonio, and we have a line already written, line X, line Y. We're going to first of all try to identify what we have to do. We're going to calculate the gradient of the slope between G640 to where the unclassified road is crossed by Easting 79 at Eccles Down. So we're talking about, let me use my laser pen now. We're talking about right here, G640, and all the way to here, where the unclassified road is crossed by Easting 79. So it's between right here and right here, these 2 points. All right. So we're now going to draw our line connecting the both of them. I'm going to place our paper right here, and we're going to mark where X and Y are. Now we're going to move our piece of paper with our markings right there on our linear scale. And as you can see, it has our two markings exceeded the 4, just a little bit over 4 kilometers. So we're going to use our pencil now and mark under the 4 kilometers because we need to compensate for the extra distance right there. So we know that it's going to be 4 kilometers. It's going to be at least 4 kilometers long, right? And we're now going to put those two markings where the 4 kilometers was and put it right under our 0. And when we count going to the left, between where the colors are separated, we're going to get, so it's 0 right here, and right here now where the line is 100 meters. Then we have 200 meters right here again, 300 meters, 400 meters. You get what I'm talking about, right? 500 meters, exactly where the lines, where the colors are separated, those are the marks. 600 meters, 700 meters, 800 meters, 900 meters, 1000 meters. But when we look back, we see that it is at 100 meters, which means that the distance is 4.1 kilometer. And now we're going to have to change that 4.1 kilometers into meters. So, having measured our horizontal distance and recording our heights, we now outline the information that we have. So the height of the spot height G640 is actually 640 meters. Remember, it's a spot height. So it means therefore that 640 meters is the height at the spot height. The height of the road is 200 meters. Now if you look carefully, you see where a 200-meter contour line actually crossed the road. And the distance between the spot height and the road is 4.1 kilometers. Therefore, we state our gradient as usual. Gradient equals vertical difference over horizontal distance. Now, we simply subtract 200 meters from 640 all over 4,100, which is our 4.1 kilometers converted into meters. Then, we now go ahead to cancel our zeros. And then we say 44 into itself is 1 time. 44 into 410, or another way to put it, 410 divided by 44 equals 9 times. Therefore, our gradient is 1 to 9, or 1 over 9. Which means to say that for every 9 meters along the horizontal distance, the height of the land increased by 1 meter. And that is our gradient. Okay, now geographers, let us assume that the height of a factory in Kelitz is 745 feet, and the height of the market near Victoria is 95 feet. The distance between them, however, is 10 kilometers. How are we going to work out this one? Well, as you noticed, both the height of the factory and the market are in feet, but the distance between them is in kilometers. It means, therefore, that we'd have to convert our 10 kilometers into feet. So how are we going to achieve this? Well, let's see. Okay, geographers, Having been presented with this unique situation, we are now going to express our formula for finding gradient, which is gradient equals vertical difference all over horizontal distance, which basically looks like this. 745 minus 95 all over 10 times 3,280. But hold up, where did that 3,280 come from? It just didn't magically appear out of the blue, right? Well, remember that the heights of both our market and factory are in feet. Therefore, the 10 kilometers, which is the distance between them, or the horizontal distance, is actually in kilometers. We cannot go any further in this calculation without converting our 10 kilometers into feet, or else our answer will just not make sense. All right? It will be totally off the chain, inaccurate. So therefore, 3,280 feet is equal to 1 kilometer. Therefore, we are going to multiply our 10 kilometers by 3,280 feet. Hence, we will get our kilometers converted into feet. Let us continue. So our vertical difference works out to be 650 all over 32,800 feet. All right, good. So the next thing we're going to do is to cancel our zeros, like that. Then we say 65 into itself, give us 1 time, good. And 65 into 3,280, or 3,280 divided by 65, gives us 50. Hence, our gradient is 1 over 50, or 1 to 50, which simply means that for every 50 feet along the horizontal distance, the vertical height, or should I say, the height of the land increases by 1 feet. Once again, for every 50 feet along the horizontal distance, the height of the land increased by 1 feet. Let us take on another challenge, shall we? Here's the next challenge. We need to find the gradient of the slope between point R and point S. Using our pencil and ruler, we draw a line connecting R to S. Already we know that point R is at height 120 meters and 40 meters. Let us say 120 feet for point R and 40 feet for point S. That is what we should say. All right. We're now going to put our paper right there. Mark where R and S are located. Where are we going to go with this strip of paper again, class? Right here on our linear scale. That is where we're going to now place our paper. And seeing that our distance is actually over the 2 kilometer mark, just over the 2 kilometer mark, we have to now place our marking right there with our pencil under the 2 kilometer mark. All right, so we have to now account for this extra distance right here, because we know now that our distance is around 2 kilometers. But how many meters? To find out, we're going to put this last marking right here under the 0, and we're going to count going to the left on our scale, on our meters part of our scale right here. So we say 100, 200. Good. So it means therefore our horizontal distance is 2.2 kilometers, or 2 kilometers 200 meters. Now that we have obtained this 2.2 kilometers, we're going to make a recording somewhere, right, on our paper. Now we're going to do our calculation. Remember, Our heights are in feet, and we need to convert this 2.2 kilometers into feet. Now, students, we are now going to express our formula. Gradient equals vertical difference all over horizontal distance, which equals to 120 minus 40. Remember, the height of point R is 120 feet and the height of point S is 40 feet. Therefore, we have to convert our 2.2 kilometers that we have actually obtained through measuring the horizontal distance by 3,280 feet, because we have to convert it to feet as well. In doing so, our vertical difference is equal to 80 all over 7,216. So it is 80 over 7,216. So we say 80 into itself one time, and 80 into 7,216 is equal to 90. Therefore, our gradient is equal to 1 over 90 or 1 to 90, which basically means that for every 90 feet traveled along the horizontal distance, the height of the land increased by 1 feet. Remember, our height is now in feet, so therefore our gradient will be expressed in feet, which is 1 to 90 or 1 over 90. Hence our explanation, our interpretation, which is for every 90 feet traveled along the horizontal distance, the height of the land increased by 1 feet. So students, let us now assume that point R and point S are still 120 meters and 40 meters respectively, but the horizontal distance between them is 2 miles. So the fact that both point R and point S are in feet, but we now have the horizontal distance in miles, means therefore we're going to have to convert the horizontal distance of 2 miles into feet. And to do this, we now have to multiply our 2 miles by 5,280 feet, because 1 mile is equal to 5,280 feet. Therefore, we multiply our 2 miles by 5,280 feet to convert it into feet, which will give us a vertical difference of 80 all over the horizontal distance of 10,560 feet. So 80 into itself one time, 80 into 10,560, or if you rather to think of it this way, 10,560 divided by 80 equals 132. Therefore, our gradient will be 1 over 132, or 1 to 132, which basically means that for every 132 feet along the horizontal distance, the height of the land increased by 1 feet. Now, of all the gradients we have calculated, geographers, can you remind me which of them would have been the steepest slope? If 1 over 9 or 1 to 9 gradient that we have calculated sometime earlier is your answer, you would have been absolutely correct, because remember, it is the smallest of them. It is the smallest of all the gradients we have calculated. All right? Therefore, it would be the steepest slope that we have right before us. This one that we have just calculated is the gentlest of all the slopes we have calculated because it has the largest ratio or fraction, which is 132, or should I say 1 to 132 or 1 over 132. The 1 to 9 or 1 over 9 is the smallest of the gradients calculated, all right, because its fraction or ratio is the smallest compared to all of them. The next steepest one would have been the 1 to 20 or 1 over 20 gradient that we have calculated earlier as well. All right. So, and then the 1 to 90 or the 1 over 90 gradient that we have also calculated earlier would have been the second gentlest of the slopes that we have. Remember, students, the greater the fraction or the ratio, the gentler the slope. The smaller the fraction or the ratio, the steeper the slope. And that is how we deal with the gradient. So now you see, everyone, everything that we have started out our session with, all those 4 pointers have now come into view, and we now should fully understand what we mean by gradient and what does it all mean. So students, let us conclude today's lesson. So geographers, so in case you want to know if the land is actually in either meters or in feet, you look in your key, especially the part of your key where you have different representations of elevation, like contour lines, trigonometrical stations, or spot heights, right? You look there. Now, normally you would see it clearly stated in this way: height in feet at ground level. Or you may see this symbol right here, the 50 with this little tail at the top. Those are key to tell you whether or not the height of the land is in feet. Whenever you see them clearly stated like that, you know that the height of the land is in feet. So you know that you may have to do a bit of conversion with the horizontal distance. Sometimes you'll also see them, express the height in meters at ground level as well. But just fair warning, most of the maps that are used these days for CSEC, they are basically in feet, all right? But you do have some of them that are in meters, which makes life a little easier for you. But nonetheless, given the key to converting and understanding how it's done, will better equip you to properly tackle that. And to aid you further, here are some figures. Now, in case the height of the land is in meters, most likely the horizontal distance, you're going to measure it in kilometers. So it means you'd have to multiply your horizontal distance, right, by 1,000 in order to convert it into meters. You may also find that the height of the land is in feet, but the horizontal distance is measured in miles. If you measure the horizontal distance in miles, then you'd have to multiply the horizontal distance you measured by 5,280 feet to convert it into feet. Similarly, if the height of the land is in meters, but your horizontal distance is in kilometers, you will then have to multiply your horizontal distance that you have measured by the 3,280 feet to convert it into feet. Hence, knowing how to plug in all of these will allow you to get an accurate gradient. So students, with that, we have concluded our lesson on gradient. Thank you very much for joining me. Just remember to click that like button, click that subscribe button, and also click that bell icon. So just in case I release new, and I will release new videos, you'll be promptly updated. So you can also view them yourselves and learn something new. Continue to work hard and love geography with all thy might. Take care, everyone.